Hi everyone, today we will revise all past paper questions from 2016 to 2024 that are related to chapter 4. Okay, let's start. Question 1. The electronic structure of atom X and Y are shown here, okay? And we have to show what is the formula of this covalent compound. If you see how many electron in the last shell of X have, has only one electron. It means it belongs to group 1. So all those elements that belong to group 1 to 4, they have the same oxidation state as like their group number. So if it belongs to group 1, it means X has the oxidation state 1. Y has how many electron in its last shell? It has 5 electron in its last shell if you count it here, right? 1, 2, 3, 4, 5. So all those group numbers that are more than 4, like 5, 6, 7, 8, their oxidation state will be 8 minus their group number. So this is like 5, right? So it will be 8 minus 5 is equal to 3. So the oxidation state of Y is actually 3. It needs 3 electron to complete its outermost shell. So now we already know the oxidation state. So now we can just cross these oxidation numbers and we can get the formula. So X will get 3 and Y will just get 1. So X3Y is the formula. So where we can find that formula? It's the option D. So option D is right. Question number 2, it's same like question 1. So let's see now how many electrons we have in this shell. 1, 2, 3, 4, 5, 6, 7. So it means Q has the oxidation state 1, right? It has one oxidation state because it just needs one electron. Whereas R has the oxidation state also 1. Why? Because it belongs to group 1, so it has the oxidation state plus 1. It just have to lose one electron. So both have the oxidation state 1, Q and R. So what will be the formula now? Q1, R1. So we can say it like QR. We don't have to represent 1. So QR is the right answer. That is option C. Question number 3. Element X and Y react to form a compound. Element X loses 2 electrons and element Y gains 1 electron. So what will be the oxidation state of X? It loses 2 electrons, so it means it will have a positive charge. Losing electron will always give you a positive charge. And how many electron it is losing? 2. So X has the oxidation state plus 2, whereas Y has gained 1 electron. So the oxidation state will be negative 1. Okay, so now we can see what will be the charge. Charge will be of course 2 plus, so that's why A and B is right. That's also right. Now let's see the formula of a compound. This charge will go here, right? So we will have X1 and Y2, where we can see X1 and Y2 in the option B. So option B is right. Question number 4. The ionic half equation for the formation of the oxygen during the electrolysis of aluminium oxide is shown. So you can see this formula now, this equation. What are the values of X and Y? So now we have to balance this equation. If you want to balance this equation, see how many oxygen we have in the product. We have 2 oxygen, right? 2 oxygen atoms, but here we have only 1 oxygen atom. So we can balance it by writing 2 here. So X value is 2. So it means C or D option can be right. Now let's see for the charge. What is the charge here? 2 negative. It means oxygen has gained 2 electrons here. So 2 2s are 4 means total now it has 4 electrons. So in the product, it will lose 4 electrons, right? So Y will be 4. I hope this one is clear. So which option is right? Now D option is right because 2 is here. So 2 2s are 4, 4 electrons. So that's why here we will have 4. Okay. So option D is correct. Question 5. Caffeine is a stimulant found in coffee. Which formula represent caffeine? So it's simple. You just have to look at the structure and count the number of each element. How many carbon we have, how many nitrogen we have, how many oxygen we have, and how many hydrogen we have. Okay, so if you count, you will see that option C is correct. We have 8 carbons, we have 10 hydrogens, 4 nitrogens, and 2 oxygen. Question number 6, it's also simple, same like question number 5. You just have to look at the formula here, okay? And then you can see the structure and then you can count the number of the elements. How many elements are present and which element is, what is the number of each element? For example, how many carbon? We have 4 carbons. Okay, hydrogen, how many hydrogen we have? Almost 8 hydrogens, yes. And oxygen, how many? We have 2. So option B is right. You can just count the numbers and you can choose the best option. Question 7, the structure of glycine is shown here. Same like question 6, you have to first find the what is the formula. So you just have to count the number of carbon, nitrogen, hydrogen, and oxygen. So these carbon is, we already have carbon, we have 2 and H5 and O2N. Okay, so that's the right formula for the glycine if you count them. So now let's see how many, the number of different elements in a glycine, how many different types of elements are present here. So we have only 4 different types of elements present here. If you see, one is carbon, other is nitrogen, third is hydrogen, and the fourth is oxygen. So option B is the right option. What is the formula of potassium oxide? Now let's see where potassium belongs to. First of all, potassium don't have this symbol. It has the case symbol. So C or D option can be right. Now potassium, if you see in the periodic table, it belongs to group 1. Okay. So it has +1 charge, it means. Okay. And oxygen, of course, it belongs to group 6. So I already told you that if the group number is greater than 4, then how you can find the oxidation state? You can find the oxidation state by -8 minus group number. So 8 minus 6 is equal to 2. Okay, so oxygen has -2 charge, right? So this is the oxidation state. Now when they will cross each other, what you will get? You will get K2 and O1. So where we can find K2O1? It is option D. So option D is the right option. Question 9. Ethyl methanoate, this is the formula, burns in excess oxygen to produce carbon dioxide in water. The equation is shown here. So what is the value of X? So you just have to balance this equation. You can just find how we can find the balanced equation. So if you see here in the product, we already know how many oxygen we need, right? It's already balanced. So we can just calculate the number of oxygen in the product. How many oxygens we have in the product? 6. 2s are 12, right? And then we have 6 again. So 18. Total 18 oxygen we have here, right? Now let's see in the reactant, how many oxygen we already have in the reactant? 4, okay? So we have 4 in this molecule. So how many 4 minus this one, 18? How many we left with? 14, right? So we need 14 oxygen here, but we already have it in the form of molecules. So what should be the number here? The number should be 7. 7 2s are 14, okay? So that's why option B is the right option. You just have to balance the equation. It's simple. Question number 10. Magnesium reacts with sulfuric acid. What are the formula of the products formed in this reaction? So now let's see when magnesium reacts. Magnesium is a metal, right? And whenever magnesium reacts with the sulfuric acid, remember that metals reacting with sulfuric acid will always produce a hydrogen gas and metal sulfate. So if you find a hydrogen gas here, yes, A or C option can be right, okay? It only produces hydrogen gas, not water, whenever metals react with sulfuric acid. So now A or C option can be right. Now let's see for the formula for magnesium sulfate. Which formula is right? If you see in the periodic table, magnesium belongs to group number 2. So magnesium oxidation state is +2, okay? It belongs to group 2. Sulfate. Sulfate is a polyatomic ion, and sulfate ions always have a -2 charge on them. So if you cross them, you see Mg2 and SO4 will also be 2 here. So both 2 will cancel each other. So now the formula will be MgSO4 only. So one magnesium need only one sulfate ion, okay? Because +2 and -2 will cancel each other. So what is the right answer? The right answer is option A. Question number 11. 3 ionic compounds of vanadium have the formula V2O, VCl2, and V2O3. What is the charge on a vanadium ion in each compound? Now let's see over here. If you see this formula V2O, so O is, if you see the number which is here, it is actually for the oxygen, right? Oxygen is -2, and then oxygen don't have any number here. It means V is 1, right? So that's why the charge on V will be +1 because it's an ionic compound. So one will be positive and the other one will be negative. Oxygen is a non-metal, so of course it will have a negative charge, and vanadium will have a positive charge. And also the vanadium belongs to metal group, right? So it's metallic. Metals always lose electron. So +1 will be the charge on V2O. So A or B option can be right. Now let's come to word VCl2. If you see Cl has 2, so it means this 2 is actually coming from the oxidation state of V. So oxidation state of V is +2, whereas chlorine oxidation state is here, V. Can you see there is only 1? So it means oxidation state of chlorine is -1. Why -1? because chlorine is a non-metal and it belongs to group 7. So its charge will be, or its oxidation state will be -1. So now V2 is +2. So which one has +2? Of course, option B. So it means option B is right. You don't have to look for the third one, but even if you still want to look, you can see vanadium. If you see, V is 2, right? So it means this 2 is actually coming from the oxidation state of oxygen. So oxidation state of oxygen is 2, right? And here the O has 3. So it means this is actually the oxidation state of V. So it is +3, okay? So that's why you see +1, +2, +3. So option B is the right option. Question number 12. What is the formula of iron 3 oxide? We have, or they have already, because iron belongs to transition metals, right? So transition metals have different oxidation states. That's why we have to write their oxidation state in front of their name, because sometimes it can be 2, sometimes it can be 3. So here they have already informed you that iron has the oxidation state 3, right? So iron is +3. Oxygen, as always, it has -2 oxidation state. So, okay, now we can cross them and we can see what will be the formula. So the oxidation state of O will go here. So Fe2 and O3 will go here. So Fe2 and O3 is the right formula. That is the option D. Question 13. Which row shows the formula of sodium carbonate, zinc nitrate, and ammonium sulfate? So now let's see one by one sodium. Sodium belongs to group 1, so it has the oxidation state +1. You can see here. Carbonate is a polyatomic ion. You have to remember the formulas of some polyatomic ions. It will be helpful for your exam. And the most common polyatomic ions are sulfate. It has a -2 charge. Carbonate, it has also -2 charge. Ammonium, then you can see over here, it has +1 charge. Nitrate ions, it has -1 charge. So you have to remember these one, okay? So it will be helpful for you to make the formulas. Now, carbonate, we already know that it has a -2 charge. So when they will cross each other, you see, this 2 will come here. So Na2 and CO3. So where you can see Na2 or CO3, that is A or B. So it means A or B option can be right. Now let's see for zinc nitrate. Zinc usually has the +2 charge. So if you see +2 charges here and then NO3, you need to remember for the zinc, mostly it has +2 charge. It is a transition metal, but still it has a +2 charge most of the time. So NO3, if you see over here, NO3, I already told you it's a polyatomic ion. You have to remember the charge on it. It is usually having a -1 charge. So when they will cross each other, zinc will be 1. And this 2 will go for all of this polyatomic ion, not only for the oxygen, okay? So you have to put the bracket and then you have to put the 2 outside. So B option is right. If you see here, the B option is right, okay? And let's see for ammonium. Ammonium has +1 charge. You have to remember this. And sulfate always have -2 charge. This is the ion. So when they will cross each other, NH4 will have the brackets and we will write the 2 outside, right? Can you see here? And the sulfate, nothing will come here because it's just 1, right? So 1 will go here. So it means it's same. So sulfate, NH4, 2 into SO4. So which option is right? B option is right. Question number 14. The formula of some ions are shown here. Which formula is not correct? So now let's see for aluminium and sulfate. Aluminium already have 3 charge and sulfate has -2 charge, right? So when they will cross each other, aluminium should have 2 here, right? Al2 and SO4 bracket 3. So can you see here? No, that's not right. So it means option A is wrong. The other option you don't have to look at. But even if you want to look, you will see that these options are correct. So only Al3SO4 into 2 is wrong because it should be Al2SO4 into 3, right? Not 3 or 2. Okay. So option A is not correct. Question 15. Aluminium oxide is an ionic compound containing Al3 and O2 ions. So simple. We just have to cross each other. These, so it will be now what? Al2O3. So Al2O3 can we find here? Yes, option A and option C, right? It can be correct. Now let's see for aluminium hydroxide. Al and then we have OH. So Al will have only 1 here, but OH will have the brackets and then 3, right? So where we can find Al and OH into 3. So it means option A is right. Al2O3 for this one and AlOH3 into for this compound. So option A is the right option. Let's see, sodium carbonate reacts with sulfuric acid to form carbon dioxide, water, and sodium salt. An incomplete equation for the reaction is shown. So what is the formula for the sodium salt? We already got carbon dioxide. We already got hydrogen here. So now we are left with only SO4 and Na2. So Na2SO4 can be the right option here. But if you want to know, you don't know the formula, so you just have to use the group numbers, right? Sodium belongs to group 1, so it will have oxidation state 1, right? And sulfate, I already told you, polyatomic ion, and it has a -2 charge. So -2 will come here, so Na will become Na2. But Na has only +1 charge, so it will go here. So what will happen? What will be the formula now? Na2SO4. Same like I showed you in the starting questions, how we can cross the oxidation state and make the formulas, okay? So the formula for for sodium sulfate will be Na2SO4. That is option C. Question 17. Iron chromate is a yellow solid. It contains ions Fe3 plus and CrO4 2 negative. So what is the formula? Simple. You just have to cross them. So now Fe will get 2, right? So Fe2, where we can find Fe2? Yes. So this option or this option can be right. Now let's see for the chromate. So chromate, outside the bracket, we have to write this 3 because this 3 will go for this one here, right? For the chromate. So how many chromates we need? 3 chromates. So Fe2CrO4 into 3 is the right answer. So option D is correct. Question 18. Iron citrate contains in its formula more than 1 ammonium ion, 1 iron ion, and 2 citrate ions. Okay, what is the formula of ammonium iron citrate? So now we have 3 ions here. So by crossing them, it's not possible that you can find, okay? You can get confused with that one. So it's better you just write what is given for you first. First, if you see that you have given ammonium ions, right? But you don't know how many ammonium ions, but you just know that it should be more than 1. Then you are giving the iron ions, right? The iron ions are here. It should be only 1. And then 2 chromate ions, right? So 2 chromate ions, and each chromate ion, if you have -4 charge, so 2 chromate ions will have how much charge? -8, right? And 1 iron has +3 charge. Ammonium is also positive. You already know that ammonium has a +1 charge. So for making a formula, you have to balance the overall formula. The overall charge should be 0. But if you see here, if we have 1 iron and 1 ammonia, what will be the charge? Total 4, right? But we have total 8 here, -8. So we have to make this one also same like this one so that we can get +8. So here they have already given you the option that iron cannot increase than 1, right? It should be only 1. So iron will, of course, will be +3. But how many ammonia now we can make? So 3, and this is -8. So -8 plus 3 is equal to how much? We need 5 ammonium ions now. So for each one will give 1 positive charge, so it will become +5, right? +5 and +3 will be +8. And this will be -8. So +8 and -8 will cancel each other. It means how many ammonia we need? We need 5 ammonia. So where is that 5 option? Yes, B option is right. 5 ammonia, 1 iron, yes, and 2 chromate ions, okay? So B option is the right option. Question number 19. Magnetite is an ore of iron which contains the ions Fe2 plus, Fe3 plus, and O negative only. What is the formula of magnetite? So same. Now we have 3 again. We have 3 different ions in magnetite. So you have to balance this formula, right? So the overall charge on this compound should be 0. So if I have one iron that has a +2 charge, right? The other iron has +3 charge, and then I have oxygen that has -2 charge. So if you see, if I have only 2 Fe, then the total charge will be +5, but oxygen is -2, so it's not balanced, right? So how I can balance it? First of all, you have to see which one is an odd number. +3 is an odd number, so we have to make it even so that we can make the even number total, right? So +3, we can make it even by multiplying with 2, right? So if I have 2 of these Fe, then what will be the total charge? +6, right? And this iron is also present in this one, right? So it also have a +2 charge. So if I take 1 of this one and 2 of this one, the total charge will be +8. So now I have to make -8 to balance this compound. So how many oxygen I have? Only 1, and it is -2. So how many oxygen I need to make this +8 to cancel this +8? So I need -8 charge, right? So what I will do, I will just multiply with 4, right? So it means I need 4 oxygen to balance these 2 Fe. right? But it is not 2Fe now, it is total 3Fe, right? Because these are 2 and this one is 3. So what will be now formula? Fe3 and O will be how many? 4, right? Because we need 4. So now the overall equation, now the overall charge will be balanced. The overall charge on this compound will be 0. Okay, so that's why this is the best option, D. You need 3 Fe and only 1 oxygen, that is, 4 oxygen, that will make -8. And this one is also +8. So overall charge is 0. So option D is the right option. Iron can react with sulfur to form 2 ionic compounds. The iron is present as Fe2 plus in one compound and Fe3 plus in other compound, but the sulfur ion is same in both the compounds. Okay, so what are the formulas? Let's see now for one F, if it is +2, and in other one, the S is -2, right? It's same. So when they will, both the charges will cancel each other because they are same, right? So what will be the formula now? It's simple, FeS. So FeS is the right answer. Now let's see for the second compound. If we have Fe with the 3 charge and S again same with -2 charge, so they will cross over each other. So what you will get? You will get Fe, this 2 will come here. So Fe2S3, Fe2S3, yes. So it means option A is the right option. Question 21. The formula of aluminium ion is Al3 plus. What is the formula of aluminium sulfate? Same, you just have to cross these oxidation states. Sulfate, I already told you, it's a polyatomic ion and it always have a -2 charge, right? So when they will cross each other, the 2 will come for the aluminium. So aluminium will be Al2 and sulfate will be SO4 into this charge, right? 3. So this is the right option. Option C is correct. Question 22. A compound contains 1 atom of calcium, 2 atoms of hydrogen, and 2 atoms of oxygen. What is the correct chemical formula of the compound? Calcium is 1, yes, right. Oxygen is 2, and hydrogen is 2. So this is one is also right. This one is also right. This one also right, and this one is also right? So but which one is the exact one? Remember that whenever you are writing a chemical formula, the metal names will come first. So here the metal name is come first, right? Here also the metal name come first, right? But here the non-metal is coming first. So B and C option is not right. Now we are just left with A and D. So if you remember calcium hydroxide, usually we write in the form of OH into 2. Why not like this? Because they both are same, right? So usually when the numbers are same, we just put a bracket and we write that number outside. So OH we can just write here and both are 2. So that's why 2 is written outside. So D is the best option. Okay, so calcium hydroxide, usually we write the chemical formula like this, CaOH into 2. Question 23. The equation represents the reaction between solid magnesium oxide and dilute hydrochloric acid to form magnesium chloride and water. Okay, so this is the formula. Which row shows the state symbol for hydrochloric acid, magnesium chloride, and water? So now in this equation, we are already given with water. Remember that water, if they have not stated the word solid or something, then water is always liquid, right? So L will be the state symbol for the water. So this one you must be sure about, that water will always have the state symbol L. No other one. So now if you find any L here, yes, only A and B option has L. A, Q is wrong, right? So it means A or B can be right. Now let's see for the another trick is that if you can see any acid in your reaction, acids or bases, so they both always will have AQ as a state symbol. Okay, so HCl should be AQ. Is it given here? Yes, AQ is here. So A and B still it's right. Now let's come to word magnesium oxide. They have not asked you. They have asked you about magnesium chloride. Yes. Now let's come to word magnesium chloride. It's a salt. So usually a salt, if it is insoluble, it will be written as S. And if it is a soluble salt, then you have to write AQ because it is making ions. So if you see this is an ionic compound, magnesium chloride. So mostly the chloride salts are soluble in water. So magnesium chloride is soluble in water, so it should not be S, it should be AQ. But even if you are not sure, of course, L is not the right option. L you cannot write with the salts. L we only write with the water. So of course, it means it's a soluble salt, so AQ is the right option. So option A is the correct option. Question 24. Sodium nitrite contains the nitrite ions. Sodium nitrite is unstable and decomposed into its element. What is the equation for the decomposition of sodium nitrite? So if you know, Sodium belongs to group 1. Nitrite, they already have given you that it has a negative charge. So when they will cross each other, what you will get? Na3, right? And this oxidation state of sodium will go here. So Na3N, where you can see Na3N. So Na3N is only B or D option. So it means B or D option can be right. Now let's balance this equation. If you see how many sodium we have, 6 here, right? Also 6 here. How many nitrogen we have here? 2, and also we have 2 here. What about this one? 6 sodium, 2 nitrogen, right? So both are balanced. Now we just have to look at the formula. For sodium, the formula is same, right? For metals, we always write their symbol or atomic form. We always write the metals in the atomic form like Na, Mg, Li. Okay, you don't have to write any other. You don't have to write it in the form of molecule. Okay, you just have to write in the form of an atom. Okay, so that's right. But now let's come toward nitrogen. Nitrogen, N2 or N. Which option is right? Usually the gases are always in the diatomic molecule form, right? And we know that nitrogen is gas at room temperature. It is a diatomic molecule, so usually in nature it exists as a molecule, not as an atom. N is an atom. It means it's wrong, okay? In nature, it will never be present in the form of an atom. So N2 is the right option because it's a molecule. It's not an atom, okay? So B is the correct option. So option B is right. Question number 25. The equation for the reaction between barium chloride and dilute sulfuric acid is shown here. Which row shows the state symbol for this equation? Now, I already told you that whenever you will see water, no water is here, okay? Whenever you will see the acid, there will always be AQ. So H2SO4 should be AQ. Can you find AQ here? Yes, A and C can be right. Now, let's see for HCl. It's also an acid, so it should be also AQ. Can you see AQ for this one? Yes, here AQ, but in C we don't have AQ. So it means A is the right option. Even if you don't know about this one, but still, you must be sure that okay, A is the right option. But I already told you most of the salts that are chloride salts they are soluble, okay? So we can write AQ for them, right? BaCl2 should be AQ. So again, you have AQ here. So BaSO4, if you don't know about the barium sulfate, but you already have other 3 options that are correct. So option A. Option A is the only right answer. Most of the sulfate salts are insoluble in the are mostly insoluble. So of course it will form the precipitate. So you can see S is the right option. So barium sulfate is insoluble. Okay, it usually is in the form of the precipitate. So even if you are not sure about that one, the other 3 you are sure, right? So AQ, AQ, AQ. So it's the only A option that has these 3 options are correct. So A is the best option. Question 26. Aluminium metal reacts with iron 3 oxide to form aluminium oxide and iron. Which chemical equation for the reaction between aluminium and iron oxide is correct? So iron oxide, we need to see what should be the formula. Iron, of course, the oxidation state is 3. It means this 3 will go for the oxygen. So now Fe2O3 is the right formula for iron oxide. Fe2O3. Can we find Fe2O3? Yes, C and D. So it means C or D option can be right. Now when it reacts with aluminium, you will get aluminium oxide. Aluminium also belong to group 3, right? So what will be the formula now when aluminium and oxygen will react? It will be Al2O3. Okay, same like iron oxide. So where you can see Al2O3, yes, both in C and D. So now we have to just balance the equation. Which equation is balanced? That will be the right one. So here, if you have 2 iron, here we have 1 iron. That's wrong, right? So you are left only with the option D. 2 iron, 2 iron. How many oxygen? 3 oxygen? Yes, 3 oxygen. And how many aluminium? 2 aluminium on both sides, in reactant and in product. So both the reactant and products are balanced. So option D is the right option. Question number 27. A solution of iron sulfate reacts with aqueous sodium hydroxide to form a red-brown precipitate. What is the balanced equation, including the state symbol for the reaction? So now, first of all, if you, to save your time, first of all, because they already ask you to include the state symbol. So you can just first start with the state symbol so that you can exclude the maximum options and you are left with only few options and then you can find the correct answer, okay? So first of all, we will look at the state symbol. We will not look at the formulas. Now let's see, they say that a solution of iron sulfate, right? So it means iron sulfate should be aqueous. So where we can find the word aqueous here? In A and in the C, right? So A or C can be right. Now let's see for aqueous sodium hydroxide. Which option can be right? A or C? Yes, both have aqueous sodium hydroxide. Now they say that a red-brown precipitate is formed, right? So if you see here, red-brown precipitate, yes, that's why it's solid, right? So this is solid and this is AQ. It means A and C both are right. Okay, now we are just left with A and C. So we have to now look for the balanced equation and also their formulas. So if you see the formula now here, for FeSO4, sulfate always have a -2 charge, right? And iron has a 3 charge, +3 oxidation state. So if you cross them, what will you get? You will get Fe2SO4 into 3, right? So is this a formula? No, it is wrong, right? So it means this formula is right, Fe2SO4 into 3. It means your option C is correct. You don't have to look for balancing the equation. You already have find the correct answer, right? So this is the trick how you can find. You don't have to look for every single statement and what has written here. If you can shortlist the right option, you just have to choose that one. Okay, so now after this one, even if you want to look, if you have time, you can look, and this equation will be the balanced equation. Okay, so Fe2SO4 into 3 is the option C is the correct option. Now again we have the same question, but here they already have you. So what is the balanced equation for this reaction? Same compounds are used and same products are there, like in question number 27. So now here, if you see, I give you the trick that you have to first look at the state symbol. But if you see here, all the state symbols are okay, right? All of them are okay. It means that now you have to look for the you have to look for their formulas. If you see here, the Fe2SO4 3 formula is also same. NaOH is also same, right? So all the formulas are also same. It means there is no problem in formula, no problem in the state symbol. Now you have to just look for balancing of the equation. So now let's see one by one and we can find the correct answer. How many iron we have here? 2 in the reactants, but in the product we have just 1. So this option is rejected. Again, let's see here. We have 2 iron, but here we have 1, rejected. C, iron is 2. Here we also have 2 iron. So now let's look for the second option. SO4, how many we have? 3 here. We also have 3 SO4 here, right? So that's right. Now how many sodium we have? We have 6 sodium. Yes, 3 2s are 6. We have 6 sodium here. Now we are left with OH. How many OH we have? We have 6 OH, right? And also if you see here, this is 3 and 3 2s are 6. So we have total 6 OH. So option C is the right option. But we can still look for the D. If there's any confusion, you see 4 iron. Yes, that's right. SO4, how many SO4 we have? 3 2s are 6. Yes, we have 6 SO4. That's right. Oh, okay. Now let's see. SO4 are 6. That's also fine. Now let's come for NaOH. How many Na we have here? 6. But how many here we have? 6 to the 12. It means D option is wrong. So option C is the only right option. Question 29. Lead nitrate. They already have given you the formula, reacts with potassium iodide to form a yellow precipitate and a soluble salt. Okay, all the formulas are already given in the question. What is the equation for the reaction? So now you just have to balance the equation actually. So iron nitrate is reacting with potassium iodide, and then you get lead iodide and then potassium nitrate. So now let's balance one by one. How many lead we have here? 1, 1. Okay. How many NO3 we have here? 2. But here we have only 1, so rejected. Pb, again here 1. NO3, how many we have? 2 here. But here in the product we have just 1. That's also rejected. Let's see here. 2 Pb we have here. Yes, but here we have 1 Pb, right? So rejected. Let's see now this one. How many lead we have? Pb, 1 in the reactant and 1 in the product. Now let's come to word for this one. NO3. How many NO3 we have? 2 here. So how many we have here? Also 2. How many potassium we have here? 2. 2 potassium, yes. And how many iodine we have here? 2. So of course we have 2 iodine here. So option D is the right option. Question 30. Silicon oxide reacts with chlorine and carbon to form liquid silicon chloride, SiCl4, and carbon dioxide gas. If the reaction is carried out at room temperature and pressure, which symbol equation represents this reaction? So it's simple. SiO2 is reacting silicon oxide. We already know the formula of silicon oxide, that is SiO2. And SiO2 is a giant covalent structure. Remember that. So it is always a solid, right? So state symbol should be solid for SiO2. Yes. So only in C and D option we have SiO2 as solid. So option C or D can be right. You don't have to look for A and B. Now let's come toward chlorine. Chlorine we already know is a gas. Okay, carbon is a solid, so everything is right here. Now let's come toward SiCl4 and CO2. First, we have to look for the state symbol, okay? We don't have to look for the balancing the equation. It will come after that. So now let's see about the state symbol for the SiCl4. They already mentioned in the question that silicon chloride is liquid, but here they have written G, okay, gas. So it means this option is wrong. Only option D is correct. So option D is the only leftover option. So option D is the right option. Question 31. When propane burns in air, carbon dioxide and water are formed. What is the chemical equation for this reaction? Simple. Propane, you have to propane. They have given you the formula already. Oxygen burning, carbon dioxide and water. You just have to balance the equation. You can see one by one the reactants and in the products. How many carbon we have? 3 here. Here we have 1, not balanced. Okay, 3 carbon, 3 carbon. Okay, that's fine. How many hydrogen we have? 8, but here 2 only. So that's also wrong. 3 carbons, yes, 3 carbon. How many hydrogen? Of course, 8 hydrogen, 8 hydrogen. How many oxygen we have here? 8 oxygen. But if you count here, how many oxygens we have here? 3 twos are 6, and then 7, 8, 9, 10. Total 10 oxygens are here. So this is also not balanced. So we are just left with the option D. So option D is the right option. You can calculate and you will find that, okay, this one is balanced, okay? Question number 32. Methane CH4 burns in air to form carbon dioxide and water. What is the balanced equation for this reaction? Again, let's see one by one. We will see it. Okay. So how many carbon we have here? 1. Here we also have 1. How many hydrogen we have here? 4 hydrogens. Yes. How many oxygen? 2 oxygen. But here we have 4 oxygen, right? 2 here, 2 here. So not balanced. Let's see for this one. Again, let's see for the oxygen because I think hydrogen and carbon are balanced. Let's see for oxygen. We have 4 oxygen here. And here we also have 4 oxygen, right? 2 and 2, 4. Now let's see once again for carbon. 1 carbon here, 1 carbon here. Both reactant products have equal carbon. Hydrogen, how many? We have 4 hydrogen. Yes, 4 hydrogen. How many oxygen? 4 oxygen. And how many oxygen here? Also 4 oxygen. So option B is the right option. Question number 33. Calcium metal react with water to form solution of calcium hydroxide and hydrogen gas. Which equation is correct? So now let's see calcium. Of course, it's a metal, it's a solid. So whenever it will react, you will get calcium hydroxide and hydrogen. So first one is already rejected because of hydrogen, because hydrogen is a diatomic molecule, right? It's a gas. So it will always be present in the form of a molecule, not in the form of atoms. So A, of course, rejected. B, again, because of hydrogen, it is rejected. So now we are just left with B and C. Hydrogen gas formula is right, but now let's look toward the formula of the calcium hydroxide. Calcium belongs to which group? Calcium belongs to group number 2. So its valence electrons are 2, right? So its oxidation state is also 2. For hydroxide ion, we know that it has a -1 charge. It's a polyatomic ion. So when they will cross each other, calcium will be 1 and OH into bracket, and then we will have 2. So OH2 is the right option. So B and C both are still right. Now we have to balance this equation. But before balancing the equation, if you see clearly, here they have used the symbol AQ for the water, but here they have used L. And I already told you for water, we always use the symbol L. So option C is right. You don't even have to look for balancing the equation. It will already be balanced, okay? So that's why option C is the right option. Question 34. Which equations are balanced? So now let's see one by one each of the equations, and then we can see which of them are balanced. Fe, how many iron we have here? 2. Also, we have 2 in the product. How many oxygen we have here? 3 and 3, 6. So how many in the product? Also 3 twos are 6. Let's see for the carbon. How many carbon we have? 3 carbon? Yes, we have 3 carbon. So it means equation 1 is balanced. So now we have to look for the option which one has equation 1. So 1 and 2 or 1 and 4. So it means we don't have to look for the option 3. It is not balanced, right? So it will save your time. You don't have to look for each of one. So now you have to just look for 2 and 4. So now let's see if we have to look for 2 and 4. Now let's see one by one. Zinc, 1. Yes, that's fine. Both sides. Carbon, how many carbon we have? 1 carbon here, 1 carbon here. That's also fine. How many oxygen we have? 3 oxygen. But here, if you see, we have 2 oxygen. So it means 2 is not balanced. So it means we are only left with the option B, that is 1 and 4. Okay. So option B is the right option. But even if you want to look, okay, 4 is balanced or not, you can still pause the video and you can see that it will be balanced. Okay. So it's just for saving your time. If you have time later, then you can recheck them. But usually, if you already find the best answer, don't waste your time on the other options. Question 35. A reaction involving aluminium is shown here. Okay, which value of x and y balance the equation? So now we don't know about aluminium on both sides, right? It's not clear. For oxygen, we also don't know, right? But hydrogen, we are sure on one side. On one side, we already know that in reactants, we need 12 hydrogens, right? So it means the product should also have 12 hydrogens. So how many hydrogen we have already here? 3. So it means we have to write the value of x as 4. So for 3, 4 into 3 will be 12, right? So that's why x value is 4. Where we can find the word 4? Yes, in D. So it means the option D is correct. You don't have to look for even y now. But even if you want to calculate the option 3, the y value will be 3. Why? If you see here, of course, x, if it is 4 here, this x is also the same. So it will also be 4, right? Now, how many oxygen we have? 4 3s are 12. So we also have 12 oxygen. But how many here are mentioned? 6. So how many left here? 6, yes. So how we can get 6 if there is 3, right? 3 into 2 will be 6. So 3 is the right option. So option D is the correct option. Question 36. Propane burns in oxygen, right? Which values of x and y balance the equation? Now let's see again. Carbon, are we sure about carbon? How many carbon we need? Okay, they are not asking about carbon. So the main question is about oxygen and, okay, hydrogen and oxygen. Now let's see. So carbon we already know. Now let's see for the hydrogen. Hydrogen and oxygen are the ones that need x and y, right? With here we need x for oxygen and here for the water. So now let's see hydrogen. We are already sure about that. How many hydrogen we have in the reactants? 8. So how much should be here? Of course, it should be 4. Right? If we have 4 here, then 4 twos are 8. So it will be balanced, right? So y is actually 4. So where we can find A or B option can be right. So now we already know that we have 4 here. So how many oxygen here now we have? Total 4. And how many oxygen we have here? 3 twos are 6. So 6 plus 4 total we have 10 oxygen in the product, right? So how many it should be in the reactant? Of course 10. So how we can get 10? So if this x is 5, then 5 into 2 will be 10. So the x value is 5. So it means option A is the correct option. Question 37. Aluminium reacts with fluorine. Which value of x, y, and z balance the equation? Aluminium on both sides we are not sure about. Fluorine we are also not sure about on the both side. But here we have the trick now because aluminium is same on both sides, right? It's still the same. But the formula of F2, if you see, it has been changed. The fluorine is F2 here and here it is F3. So now this is the trick. Now what we can do, we can try to make them balance, this F2 and F3. So if F is 3, how I can balance it? By multiplying it with, this is the odd number, right? So odd number, we can make it an even number. 3 twos are 6. So Z value can be 2. So it will become 6. So if this one becomes 6, then how many y you need? You also need 3y, right? So 3y will also make it 6. So now we know the value of y and z, where you can find 3 and 2. 3 and 2. So B is the only option where you can find 3 and 2, right? So B is the right option, but still you can look for it. If this is 2, right, Z, then X should also be 2, right? Because we just need 2 aluminium. So X is 2. So B option is the correct option. Question 38, the equation for the reaction between phosphorus and oxygen is shown over here. And what are the values of X, Y, and Z balance the equation? Again, if you see here, so we are not sure about P4 how many P4 are total here we need, or how many here, okay, or how many phosphorus we need in the reactant and product, and how many oxygen. So now if you see here, this is an odd number, right? So if this is an odd number, you can try to make, and this one is even, oxygen is even here. So you can try to make it even on both sides, first of all. So if you multiply this one with 2, it will become even. Oxygen will become 10 in the product, right? That's an even number. So Y will be also 5, right? Then it will become what? It will become also 10. So oxygen will be balanced on both sides. So Y value will be 5 and Z value will be 2, right? So both A and C can be right. Now we are just left with the X value. So if you see, if this one is 2, so how many phosphorus we have in the product? 4, which is already 4 here, right? So we don't need to put any other coefficient. So X value should be 1. So 1 is the right option. So A is the correct, in which X is 1, Y is 5, and Z is 2. So option A is the correct option. Question 39. Which formula is an empirical formula? Now, what is empirical formula? It's the shortest formula, or we can say the simplest whole number ratio of any formula, in which you cannot further divide into smaller elements. Okay, so how you can know that which one will be an empirical formula? First of all, if you have so many options, you have to first look at the one which has the simplest number 1 in its formula. So if you can see 1 in any of its formula, it's only A. Can you see that oxygen has 1? How many oxygen we have? 1. So we cannot make it more shorter. But if you see B, we can make it more shorter. This 2 can become 1, this H can become 4, and this C will become then 2, right? So we can still make it short, but this one cannot be made short. So that's why this is the trick. You can find that A is the correct option. Okay, this is the simplest formula that cannot be further divided into more simplest ones. So empirical formula is the, you can say, is the ratio of the elements present in a formula. Okay, now let's see question number 40. Analysis of a compound formed between magnesium and nitrogen show it contained 14.4 gram of magnesium and 5.6 gram of nitrogen. What is the empirical formula of the compound? So remember that whenever you got a question like this one, and it is very common nowadays in the past papers, last 3 years, this question is coming again and again to find the empirical formula. So first of all, to find the empirical formula, you have to calculate the number of moles. And how you can calculate the number of moles, you already know the formula. That is the mass given divided by the formula mass, right? Or the atomic mass, which is given in your periodic table, right? So atomic masses are already given in your periodic table, but you should know the given mass. So if you see this question, the mass is already given, right? For nitrogen and for magnesium, this is for magnesium, and for nitrogen, it is already given. So now step 1 is that you have to see that, okay, the masses are given. For magnesium, it is 14.4, and nitrogen, it is 5.6. Now the second step will, you have to find the number of moles, right? So because the moles will always decide the empirical formula. So let's see the mole of magnesium, how many we have. Given mass divided by the mass of the magnesium. So mass of magnesium, how you can find? You can just look at the periodic table, which will be given in your exam. So you can just divide them, and the value of this one is in the, if you see, it is in the decimal form, right? Same is for the moles of nitrogen. You can find given mass is 5.6, and the mass of the nitrogen from the periodic table is 14, right? So what you will get here now, 0.4 mole. So both are now not in a whole number. So how you can calculate the number of moles in whole? You just have to simply divide with the shortest number. You have to find the mole ratio. How you will find the mole ratio? You just have to divide both by the smaller number. And which one is smaller? Of course, 0.4 is the smaller one. So if you divide both of them, for nitrogen, you will get 1. But for magnesium, again, you will get 1.5. So you can make it double so that it can become a whole. So 1.5 will become 3 and 1 will become 2, right? So that's why now the formula for this compound will be, how many mg you need? 3, right? So mg will be 3, and nitrogen, how many? 2 nitrogens, right? So mg 3 and 2 is the right answer. Option B is the correct option. Now let's see question 41. Again, they are asking you the empirical formula, and I already told you that you must have to find the moles, and mole will decide the empirical formula. For moles, the formula is given mass divided by the given mass divided by the relative atomic mass, that is from your periodic table. Okay, so now we are already given the mass, but it is in the percentage, so you can just assume that total mass is actually 100, and then 34.5 is calcium, 24.1 gram is silicon, and 41.4 gram is oxygen. And then you can just start calculating the moles. So once you calculate the moles, you see here now already that for calcium, silicon, what are the answers? So now you have to, because they are all in the decimal, they are not in the whole number. So you can just calculate by dividing them with the shortest number. So which one of the value is shortest? Of course, these two are the shortest one. You can divide them. So what we will get, calcium will be 1, of course, silicon will also be 1, and this one you will get 3, right? So it means how many calcium you have in this formula? 1 calcium, 1 silicon. Okay, 1 calcium, 1 silicon, and 3 oxygen, right? So CaSiO3 is the right empirical formula. So option B is correct. Question 42. Again, the same question. You have to find the empirical formula. You just have to see what is given. The given is actually the mass, right? So what is the mass? A compound is analyzed and found to contain 85.7% carbon. So carbon is 85.7 gram, we can say, and 14.3 gram is hydrogen, right? Just convert it into number of moles. How many moles you get? 7.14 moles of carbon, and hydrogen has 14.3. So if you see which one is the smallest one, 7. So you have to divide 7 with both. So what you will get? Carbon 1 and hydrogen 2. So what will be the now formula? CH2. Okay, so CH2 is the right option. That is option B. Question 43. Compound X contains the carbon, hydrogen, and oxygen only. It by mass, it contains this much carbon, this much hydrogen, but they did not give you oxygen, right? And this one is in the percentage already. So percentage is always the total will be 100, right? So you can just calculate the oxygen mass first, and oxygen mass will be 100 minus 26.7 minus 2.2. So how much you will get? 71.1. Now we already know all the masses. Again, convert these mass into moles. Once you convert it into moles, then divide. If the number is not a whole number, then you have to divide them by the shortest number. Okay, once you divide by the shortest smallest number, you will get the exact answer, and that will be your formula, right? So that's why if you calculate like this, you will get option D will be the right option, CHO2. So you can just do all these questions related to empirical formula the way I have showed you in question 41, 42. Okay, you can do just that, just like that. Question 44, again, it's same. A hydrocarbon contains 85.7 of the carbon by mass. What is the empirical formula? Simple. You have to first find the hydrogen mass. How you can find? 100 minus 85.7. Now you have already the given masses. So what you will do? The next step will be to find the number of moles. So once you find the number of moles and it is in the decimal form, then you have to calculate it into, say, you have to convert it into simplest whole number ratio. Once you get the simplest whole number ratio, that will decide the empirical formula. So option A is the right option for this question. You can try yourself the same way I have shown you for question 41, 40, and 42. Okay. Question 45 is also the same. You have to just find the empirical formula the way I told you again. Okay. How? To find the first, the number of moles. And after finding the number of moles, it will be easier. It will be easier for you to find the whole number ratio, and that whole number ratio will decide the empirical formula. So the empirical formula for this question is H3PO3. I already have told you how to calculate it. So you can use the same formula again and again in all these questions. You can try yourself also, and you will see that the option C is the correct option. Question 46, again, it is about the empirical formula. So you have to use the same method. I already told you about the calculating the number of moles. So for always to find the empirical formula, you have to find the number of moles. And to find the number of moles, you have to remember this formula of moles is equal to mass given divided by the relative atomic mass. Okay, and relative atomic mass you can easily get from the periodic table. So option C is the right option for this question. Fe2O3 will be the formula when you will calculate the empirical formula for this question. Question 47. So the number of the moles of atom H, Y, and Z in a compound are shown. What is the formula of this compound? So now they are asking you about the formula of this compound, but here they have not give. They have. I told you that you have to calculate what? You have to calculate the number of moles. So now they already have given you the number of moles, right? So now you just don't have to use the formula of the moles. Given mass divided by the atomic mass. Why? Because you already have the moles now. But these moles, if you see them, the value is not in the whole number. So you have to do just one step, that you have to find the mole ratio in whole number, okay? By dividing by the smallest number of moles. So which one is the smallest one? 0.3 is the smallest one. So we will divide 0.3 with each of them. So what will be the value for X now? If you divide 0.6 by 0.3, you will get answer 2. So X should be 2. Where you can find C or D. Okay. C or D option can be right. Now let's see for Y. If you divide Y with 0.3, you will get 4, right? So Y should be 4. It means option D is the correct option. And if you divide 0.3 with this one, you of course you will just get 1. So X2, Y4, Z1 is the right option, and that is option D. Question 48. A compound X contains 40% carbon. Okay. We have given, they have given you the masses. Now, okay. Now, relative molecular mass is also given. This is a new information right here. Whenever we were finding the empirical formula, we were not given the molecular mass because we don't need. But here, actually, they want you to tell the molecular formula. They are not asking about the empirical formula. But still, if they ask you the molecular formula, you cannot find the molecular formula until you know the empirical formula. Because empirical formula, I already told you, is the simplest whole number ratio of the elements present in a compound, right? So it's again the same steps you have to do. You have to first find the empirical formula, and then your answer was right, for other MCQs. But if they ask you molecular formula, you have to do 2 more steps after finding the empirical formula. Okay, how? Let's see. Now we are already given the mass, right? So first step for the empirical formula was to calculate the number of moles. We already calculated the number of moles, right? So now we will divide with the shortest number, that is 3.33. So what we will get? Carbon 1, hydrogen how many? 2, and oxygen 1. So this is our now empirical formula, right? So up till here, now we already know. So what will be the next step once you know the empirical formula? How you can calculate your molecular formula? For this, you have to find the mass of this empirical formula. Whatever you have to first find the mass of this empirical formula. What is the mass of one carbon? It's 12. You can see from the periodic table, hydrogen, it will be 2 because we have 2 hydrogen. Each one has 1 mass, and oxygen is 16. So if you add them together, the relative mass will be 30, right? So now this mass will help us. You see, the relative molecular mass is 60. So what you will do, you will just divide the empirical mass divided by the, molecular mass on the top you have to write, and you have to divide it with the empirical formula mass. You can see over here, right? So molecular mass divided by empirical formula mass, and your answer is 2. Now this 2 you can just multiply with your empirical formula, and it's simple, you will get your molecular formula. So CH2O was your empirical formula, right? So if you multiply everything with 2 here, you see C2H4O2 is the right option. So C2H4O2, yes, option D. So option D is the correct option. I hope it's clear to you that whenever they ask you about the empirical formula, you just have to stop up till finding the number of the moles and then converting into the whole number, right? But if they ask you about the molecular formula, you have to first find the empirical formula. After finding empirical formula, you have to do 2 more steps. You have to find first the mass of the empirical formula, right? And then the second step you will do is to divide that mass, both the mass, molecular mass, and the empirical formula mass with each other. And of course, the bigger one will come on the top, and the smallest, of course, empirical formula will always be smaller. It will come at the bottom. And then whatever the value you get, you have to just multiply. If it's 2, 3, 4, whatever, you have to just multiply it with the empirical formula. And that answer will be your actual answer. Question number 49. The relative molecular mass of alcohol is this one. Which row shows the empirical formula and molecular formula for this alcohol? So it's simple. You just have to do like question number question number 48. And first you have to find the empirical formula. And after finding the empirical formula, you have to calculate you have to multiply both the mass. You see, you have to divide 88 by the empirical formula mass. So once you divide whatever the value you will get, you have to just multiply with the empirical formula, and then you will get your molecular formula. So if you do this question, you can pause the video, you can try yourself, and you will see that the B option will be the right option, okay? Question number 50. What is the empirical formula for ethanoic acid? So now for ethanoic acid, they have not given you anything. You need to remember actually the formula for ethanoic acid. Then you can find the empirical formula. So it's related to organic chemistry. So when we will come to the organic chemistry topic, I will make it clear how you can find the formulas and how you can make it. But you have to remember now, just for your understanding, ETH, whenever you see the word ETH in for organic compounds, it means it has only 2 carbon, right? And oic acid means, of course, it has COOH group. So what is the general formula for the COOH carboxylic acids, because it belongs to carboxylic acid group? So the general formula I already have given you here. It is CnH2n plus 1 COH. Okay. So 1 carbon we already have here, right? I already told you ethanol has only 2 carbons. So 1 carbon we already have here. So we have to write here 1 now, because you cannot write 2 here. If you write 2 here, then we will have total 3 carbons. So that's the trick in carboxylic acid. Always, if they are asking you ethanoic acid or double anything, you have to write 1 less. Okay, it is 2 carbon. You have to write 1 here for carboxylic acid. Why? Because we already have 1 carbon here in the COH group. So if you have 1 carbon here, so how many? 1 multiplied by 2. So 2 plus 1 is 3. So now the formula is CH3COOH, right? So CH3COOH is the formula for ethanoic acid. Now let's see what will be the empirical formula. This is the molecular formula. They are asking you about the empirical formula. So you have to make it short. How many carbon we have? 2. How many hydrogen we have? 4. And how many oxygen we have? 2. So all are even numbers, so we can make them shorter. If you divide all of them with the 2, what will happen? Carbon will become 1, hydrogen will become 2, and oxygen will also become 1. So CH2 is the empirical formula for the ethanoic acid. That is option B. Question 51. The incomplete equation for the photosynthesis is shown here. Compound P is a product of the reaction. Which row describes the values of W, X, Y, and Y and gives the empirical formula of the compound P? So first of all, you have to remember the photosynthesis equation. It's already given in your book, so you have to remember that one. Otherwise, you guys will forget that which is the product. You cannot find the product from here. But the students who are already studying the biology, they know that photosynthesis always give you glucose and oxygen. So you have to remember the formula of the glucose, right? Glucose formula is C6H12O6, right? So we already know that P is C6H12O6. I have given you the equation for this. This equation I have already given you here, the photosynthesis, right? So once you know that, okay, P is C6H12O6, so now you have to find the value of W, X, and Y. So how many carbon we have here? C6, right? So if you have 6 carbon here, right? So what will be the option here now? Carbon are 6, or you can just look from here, right? If your carbon is 6, it means in the product you have 6 carbon, so it should also be 6 here. So W should be 6, right? Now we have W is 6. Let's see for the hydrogen. Now hydrogen, how many hydrogen we have? We have no hydrogen here, but we have hydrogen in this product. So how many hydrogen we have here? 12. So how many here? 2. So it should be 6 here, right? So again, W is 6, X is also 6, both are 6. So now we are left with only oxygen. Now let's count how many oxygen we have in the reactant, right? So if you see in the reactant, this one is 6, so it means we have total 12 oxygen, right? we have total 12 oxygen here. And how many oxygen here? 6 oxygen. So total together 12 plus 6 is 18, right? So out of those 18 in this formula, in the P, we have already have 6. So 18 minus 6 is 12. So it means we need 12 oxygen here, right? So 12 oxygen means if oxygen is 2, then what you will get here? 6. So 6 twos are 12. So it means W is also 6, X is also 6, and Y is also 6. So X, Y, and W are all the same. So it means A or B option is right. Now let's see towards the formula. Please read the question carefully. They ask you empirical formula. They did not ask you the actual formula, right? Don't choose this option C6H12O6. They ask the empirical formula. It means it's the simplest whole number ratio. So which one is the smallest number among them? 6. So we can divide everything by 6. So what we will get? C1, H2, and O6, right? You cannot further divide this one. This is the simplest whole number ratio for the glucose. So CH2O, and this option A is the right option. Question 52. The relative atomic mass of chlorine is 35.5. When calculating the relative atomic mass, which particle is the mass of chlorine atom compared to? So this is the actually the definition of relative atomic mass. So whenever you are comparing the relative atomics, how we have calculated in our periodic table, it has been calculated by comparing with the carbon 12 atom, right? An atom of carbon 12. You already know that. Everyone knows this one. So option C is correct. This is simple. Same for the question number 53. The relative atomic mass of an element is determined by comparing the mass of one atom of the element with the mass of one atom of the element Q. So which one we have to compare with? We always compare with the carbon 12, right? So if you can see what is Q? Carbon, of course. So option A is the right option. Question 54. A compound has the formula CH3COO2H. How should the relative molecular mass? So molecular atomic mass means is the mass of an atom. Molecular mass means it's the mass of the molecule. So this is now our molecule. Of course, a compound is also a molecule. So this is if it's a molecule, we have to just find the mass. How we can find the mass? It's simple. You just have to add the mass of all these elements present in this compound. Okay, and then you will get the mass. So how we can calculate this one? How many carbon we have here actually? We have 2 carbons, right? So we can just multiply 2 with the mass of the carbon. So what is the mass of carbon? You can look at the periodic table. It's 12. So 12 multiplied by 2. Can you find anywhere? Yes, it's only in the option D. Nowhere else you can find it because here it is 3 and then again we have 2. So total 5. That's wrong. We have only 2 carbons, right? Then how many hydrogen we have? We can just look again. 4 hydrogens, right? So 4 multiplied by atomic mass of the hydrogen, that is 1. Then add again, what we have to add? We have to add the oxygen. How many oxygen we have? 2. So 2 multiplied by 16, the atomic mass of the oxygen. So this is how we will calculate the molecular mass of the compound. So option D is the right option. Question 55. The formula of a compound containing element X is Na2X2O3. The relative formula mass of compound is 158. What is the relative atomic mass of X? So I already told you that relative formula mass, what does it mean? How you can find it? You just have to add the masses of those elements present in that compound. So we already know the compound, that is Na2X2O3. Okay, we already know their masses, but we don't know about the X2, right? But we know the total of it. The total of the formula mass is actually 158. So 158 is equal to the mass of Na, mass of X, and mass of oxygen. So what is the mass of Na? It's of course 23 multiplied by 2 because we have 2 elements of Na, right? And we have 2 elements of Ar, right? Oh, sorry, of X. And then you have to find the relative atomic mass of the oxygen. We already know that it is 16 from the periodic table and you have to multiply with 3. So all these answers, when you will calculate and you will reshuffle them together, you will get an answer A, that is 32. Okay, so 32 is the right answer. It means the value of X is actually 32. Okay. Question 56. A sample of 16 gram of metal oxide is reduced to 12.8 gram of the metal. What is the relative atomic mass of M? Okay. So how we can find the atomic mass, relative atomic mass? It's already given in the periodic table, right? But here they have not mentioned which M is this one. We don't know about this metal. Okay, so it means we are not sure about we have to find the relative atomic mass. So for relative atomic mass, now you should know the number of moles or of the given mass. So if you see here, we are not given the number of moles, right? But we are given the mass. The mass is given for us about the metal, but we have not been given the moles. So now moles is also missing. The relative atomic mass we have to find. So we have just one thing. That is actually the given mass. So now what else we have to find now? The number of moles. So how we can find the number of moles? This is a formula, right? The number of moles is equal to mass of a substance divided by molar mass. This one we have to calculate. This one we already have given. But this one is missing. We have to calculate this one so we can get to the molar mass. So now what should we do? First of all, we have to find what the things we are given already. We are given that 12.8 gram is the mass of the metal. Yes, that's right. Okay, so what about the product? The product was metal oxide and it was 16 gram, right? So now we know that metal is 12.8 gram in this 16 and the remaining one is actually oxygen, right? So we can find from the oxygen, that's okay. Oxygen is how much now? 3.2 gram. So now we know the mass of oxygen, right? The given mass of oxygen. And we also know the molar mass of oxygen. So it will be easy for us to find the moles of oxygen. That's why we can easily find the mole of oxygen first, because mole of oxygen will help us to find the moles of M. Okay, because our actual target is to find the number of moles of M. So for that one, first we have to find the number of moles of oxygen. Now let's calculate the number of moles of oxygen. How we can find the given mass is 3.2, right? And the relative mass of oxygen is actually, because this is only one oxygen, so it is 16, right? So if you divide, you will get 0.2 mole, right? So now you already know that 0.2 mole is the mole of oxygen. Now let's come back towards this metal oxide formula. If you see, one oxygen needs 1 m, one metal, right? 1 mole of oxygen will need 1 mole of metal. So 0.2 will need how many moles of metal? Of course, 0.2. It will be equal. So it means now we know the number of moles of M is also 0.2. And we are already given the mass, right? So now we will put this number of moles is 0.2 and the mass of a substance is actually 12.8. So when you reshuffle this formula, you will see that 12.8 divided by 0.2 and you will get a 64 answer. So 64 is the relative atomic mass of this metal. So 64 is the right answer. Question 57. A compound has the formula XF2 and has the relative mass of 70. What is element X? This is simple again. We have to just find the mass of X, right? So we already have the relative mass is equal to mass of each element of that compound. So X plus F2. X we don't know, plus F2. So 2 multiplied by the mass of fluorine. So when you multiply the mass of fluorine, you will get 38. And when you reshuffle it, 70 minus 38, the answer is 32. So if you look at your periodic table, the mass 32 is of sulfur. So option C is the right option. Question 58. A compound with the formula XF2 has a relative formula mass of 78. What is element X now? Again, same question. So you already know that relative mass is 78. And how you find the relative mass? By adding all the mass of the elements in that compound. X plus F2, right? F is 19. The mass of fluorine is 19 multiplied by 2. So what you will get? You will get 38. So 38, when it will go here, you will get the answer 40. And 40 is for calcium. So answer B is correct. You can just calculate it. It's as simple. Question 59. A compound of element X has the formula X2O and relative formula mass of 144. What is the element X? Again, this is the same question repeated by giving different options and different values. So relative mass, formula mass is always equal to the sum of all the atomic masses, right? So what is the sum of this mass is 2 into X, right? And then O. So X we don't know, we have to calculate. 16 we already know for oxygen. So this 16 will go here, it will be minus, and then this 2 will come and divide by 128. So 64 is the answer. So what is the which which element has the 64 mass? If you look at your periodic table, it is actually copper. So copper is the right answer. This is actually Cu2O. So copper oxide is the formula of this compound. Okay, let's see question number 60. What is the relative molecular mass of sulfur dioxide? So it's simple. We have to know the formula of sulfur dioxide. So it's already given, sulfur S, and dioxide means di means 2. So 2 oxygen molecules are present there. So you can just simply add the mass of the sulfur, that is 32. You can look at the periodic table, and mass of oxygen is 16. But we have 2 oxygen atoms, right? So 16 multiplied by 2, again you have to 16 multiplied by 2 plus 32 for sulfur. So if you add them together, the answer will be 64. So the option D is the right option.